All right, so we will get started with the homework. For the homework, I gave you a triangle and I asked you to find all the missing parts. All right, so we had triangle ABC here. We were given two of the angles and one of the sides, right? So that's what we were talking about yesterday. This would be angle, side, right? So that's one of the instances that we can use our law of sines. So just for organization purposes, all right, we're going to write down what we know. I don't know angle A, right? That's going to be one of the things that I find. Angle B is 44 degrees. Angle C is 53 degrees. And the only side I know is side B, which is 7, whatever, inches, feet, whatever we're talking. So with this setup, we're looking for one angle and two sides. Now I'm going to do it a little differently. I'm going to go out of order of what we did. And for the homework, I told you that you may not be able to answer the questions in order. You may have to find one out before the other. You could have started off by finding C first, but I'm going to find angle A first because that's a little easier. Right, because we have that angle A is the remainder, what's left over, of the sum of these two. All right, so I add up 53 and 44. I subtract that from 180, and we get angle 3 is 83 degrees. So we can fill that in, 83 degrees. So now that we got all of our angles, okay, it's a little easier to set up using the law of sines. All right, so we're going to have two instances, one where I'm finding side A, one where I'm finding side B. I'm sorry, side C. For both of those, I'm going to use angle B and side B as my proportions. All right, so for the first one, we'll set up for A. I'll have B, which is 7, over the sine of B, which is the sine of 44. And that's going to equal my side A over the sine of 83. So cross multiplying and solving, I get that A is equal to 7 times the sine of 83 divided by the sine of 44. Okay, degrees. Be careful. Make sure you are in degree mode, right? We don't want to be in radian mode. And when I calculate this, I get 10.00 something. So we're just going to call it 10. It's about 10. So side A is about 10. Now, we don't have all the sides, but so far it looks like it makes sense. 7 is across from 44. 83 is larger than 44. 10 is larger than 7. So our proportions in that sense are matching up so far. So far, so good. Let me put in, I have A is 10. Now C, right, I'm going to do the same thing. I'm going to use B. So I have 7 over the sine of 44 again. Now that's going to equal C over the sine of angle C, which is 53 degrees. So again, we cross multiply, and I'm going to get C is equal to 7 now times the sine of 53 over, again, the sine of 44. So again, just be careful plugging this in. If you're typing it all in at once, make sure you use parentheses around the numerator, okay, or brackets or whatever, and then make sure you close your parentheses when you're done with the sine part. And here, we're going to get about 8. So almost another whole number. I think it's a little off, but we can round it to 8. All right, so there are our 3 missing parts. Any questions? Okay. All right, so that's the homework. So let us move this down now. Okay, so now we're going to look at a different example today. And this has an interesting name. Oh, that's not a triangle. It's supposed to be an A. Sorry, guys, I'm getting used to this. I got this tablet thing yesterday, so. Okay, so this is a little interesting. Side-side angle. Now, going back to geometry, we are not allowed to use side-side angle to prove congruence or similarity. Okay, it's not enough information to fill out the rest of the triangle. Because when we're given a triangle, if I know two of the sides, and I'm given an angle on the outside, so say we're given this angle, that's not enough information to prove that it's, you know, maybe similar to this smaller triangle, right? Because, again, the way our opposite angles and sides interact, right? So if I know B, angle B, it doesn't really help me if I know side B, because they are related, all right? If instead of B, no, I don't want to do that. If instead of B, I was given side C, which was over here, that's better, because now I have these two sides, and this angle B tells me about what's going on my other side. All right, so when we have side-side angle, and again, you know, I don't think I didn't have you guys for geometry. If you flip that, you're not allowed to write S in my class, okay? It's not a way. But when we are solving the triangle, when we are using the law of sines, we get an interesting scenario. Okay, so we are looking at a triangle. Let me see. So we are going to consider a triangle where A, B, and angle A. Oh, that's ugly. Okay, where A, B, and angle A are given. So a little different than what we have here. We're gonna switch this. I don't need this anymore. Why won't you erase? All right, whatever. And angle A. Okay. So we have three scenarios, and each scenario has its own kind of subcategories. First, if angle A is acute. Oh, I'm sorry. One thing that I forgot to talk about. Now that we're talking about this, we have to consider also the height of our triangle. So remember, the height of the triangle makes a 90 degrees with a base, and it goes to one of the other vertex. So it's either inside the triangle, like this, if it's an acute triangle, or it is outside the triangle if we have obtuse. Right. So if A is acute, if angle A is acute, I'll put it over here this time. Okay, and we have h there. If, how do I want to say this? Okay, if A is less than h, if your side A is less than h, then we encounter a strange situation where we don't have a triangle. Okay, if this A was shorter than h, my triangle would, maybe stop here, and this part would be empty. So for that, there is no solution. There are no possible triangles. Okay, if A and H are equal, if they are the same, then we have a right triangle. And there is, that's not how you spell solution. So there's one solution, right? Because we have a right triangle. Then, okay, this is going to get a little out there. So this is, what do I want to call this? I already named that one. I'll just put a point here. If A is greater than or equal to H, then we have two possible solutions. All right, and I'll go over an example with that. Then if A is obtuse, again, we have A is less than H, gives us no solution. Okay. We'd end up with a similar situation. So if I have an obtuse angle here, right, this would be my angle A. This would be my H here. So if A was less than H, I wouldn't end up with a full triangle. They would never meet side A. Okay. And then if, I'm sorry, this is supposed to be B, side B. And then if A is greater than B, then we have a solution. All right, so there's a lot of information there. We'll take a look at the different examples. All right, let's look at some examples. Everybody good with this? I can scroll up.
Yep, all good.
Okay.
Mr. Moore, can you just go back up a little bit?
Yeah, sure. 1 second. Like there, that's good.
Yeah. All right, I'm done. So you can just go back down. Thank you.
Okay. You're welcome. All right, so for this one, we have a triangle. I have angle A is 42 degrees. I have side A is 22. I have side B is 12. All right, so with this, there's also a slightly different setup in our first step. So if I look at what I'm given A and angle A. Okay, thank you for letting me know, Mary. I have side B, but I don't know angle B. But then if I look at C, I don't know anything about those. So right off the bat, I can't do anything with C. I can't find angle C because I don't know angle B to add them up. And I can't use my law of sines to find any part if I don't know either the top or the bottom. So the first thing that we have to solve here is for angle B. All right, so this is something that we haven't done. Again, it's another reason I wanted to show this to you. So for A, again, we have everything we need. So I'm going to flip it this time. I'm going to do the sine on top. So I have the sine of 42 over 22, and that's going to equal the sine of B over 12. So just like before, we cross multiply. I get 12 times the sine of 42 equals 22 times the sine of B. And again, I'm eventually trying to isolate that B there. So I'm going to divide both sides by 22. Let me fix that. All right, so now I have the sine of B is equal to this 12 sine 42 over 22. So remember, if I want to solve for an angle and I need to get rid of sine, I have to take the inverse sine of both sides. All right, they eliminate each other over there. So I'm left with angle B is equal to the inverse sine of all of this. All right, so I can calculate this. All right, so I'm going to do that. So I have 12 sine of 42 divided by 22. All right, so this part here is more than likely going to get you some decimal. Remember, we can't plug in anything greater than 1 into inverse sine. So if you end up with something larger than 1, something went wrong. All right. And we want to be as accurate as possible. So I'm going to use a few decimal points, usually more than if I was just answering a question. So calculating this, I get 0.36498, we'll say, and then it's a 0 after the 8. All right. The more decimal points you use here, the more accurate you're going to be. Then we take the inverse sine of that, and we get angle B is about 21.4 degrees. All right, so that 21.4 will go there. Now that we have that, again, I can't find side C right now because I don't have angle C, but angle C is pretty easy. All right, so I subtract the sum of 42 and 21.4 from 180. So I get angle C is 116.6 degrees. And then side C follows with our law of sines. And again, I'm going to pick the original stuff I was given. So I'm going to stick with A. And now that I'm looking for a side, I'm going to switch this back around. I'm going to flip it. And I'm going to have 22 over the sine of 42 equals C over the sine of 116.6 degrees. All right, so we get C is equal to 22 sine of 116.6 all over the sine of 42. Right, again, just be careful plugging it in. 22 sine of 116.6 divided by sine of 42. And I get side C is about 29.4. Nope, not 9. Right. And looking at our angles and sides, angle C is the greatest by far, and side C is the largest side there. Okay, and then 21.9 is the smallest angle, so side B, 12 is your smallest side. All right. Any questions there? All right, so I'm going to give you one more problem where it's set up like this, where you're going to have to find an angle first, and then you can fill out the rest how you'd like. All right. And then tomorrow we'll take a look at some no solution cases, because, yeah, we saw that up above. Can I? Nope. Nope. That's interesting. I can't scroll with just the pen. Okay. So also just something else I wanted to say, with this new stuff, I am able to export my notes. So along with the video, okay, I should be posting all these notes with it. All right. So now you guys can watch the video, or if you don't have time, or if you don't need to watch the whole video and you just need to remember, oh, what do I do here? You can reference the notes that we have here now. So I think that's pretty neat. All right, guys, keep an eye out for the assignment. Have a good day, and I'll see you tomorrow.